Hello, this is Miss McCauley, and this is part 2 of algebraic properties of addition. If you understood it from part 1 and completed your notes, you may skip this video. But if you want to watch and fill out the note sheet at this time and get a little bit more understanding, you can watch part 2. And go right to your note sheet, the property play, and I'm going to help you fill out anything that you may not already have had. Okay, so we already started with the commutative property of addition. The commutative property of addition says that A plus B equals B plus A, and that is true for any numbers. So let's write a few examples here. We wrote whole numbers already, so we could say 3 plus 4 equals 4 plus 3. They both equal 7, so this is true. We could also use a fraction. We could say 1/2 plus 1/4 is the same thing as 1/4 plus 1/2. We just switch the order of the numbers, but the answer will be the same. 1/2 plus 1/4, you should know, is 3/4, and 1/4 plus 1/2 is also 3/4. Okay, go ahead and add another page. And you may have more room than I do, but let's go ahead and add another page and do a few more examples. What if we have negative numbers? What if we have integers and we have negative integers? A -3 plus a -2, does that equal a -2 plus a -3? It should, but let's just prove it. -3 plus -2 is -5. -2 plus -3 is -5. Remember, the balloon starts at a -3. If we add 2 bags of sand, the balloon will go down. It's the same thing if we start at -2 and add 3 bags of sand, we will still go down to -5. It's true. Is the commutative property true for decimals? I think it is, but let's prove it. 2 plus 1 plus 4 plus 3, 4.3, sorry, is the same thing as 4.3 plus 2.1. Okay, we can prove that by saying that that is 6.4 still equals 6.4 over here. All true. Now, does the commutative property work for subtraction? Let's see. Does 2 minus 1 equal 1 minus 2? 2 minus 1 is 1. 1 minus 2 is the same thing. KFC, 1 plus a -2 is -1. So this is not true at all. Let's make a big red not equal and write commutative does not apply to subtraction. I'm running out of room. Let's see if I can make some more room. Okay, you guys will probably have more room than me. Okay, oh, it's not showing up on my screen, is it? Let's try to make that a little bit bigger than for you, because that was not showing up. I'll add another page. Anyway, there was a little bit of a lag there, so I'll write it again. 2 minus 1 does not equal 1 minus 2. They are not true. So it does not, commutative property does not work for subtraction. Does not apply to subtraction. Okay, let's go ahead and do the associative property next. You probably have a lot more room than I do, but I'm going to just use another piece of paper so I have enough room. The associative property of addition. Okay, this is our grouping property. You may want to write grouping underneath here so that you remember that this is the one that refers to groups. Okay, this simply says that A plus B plus C equals A plus B plus C. You can change the groups. Okay, you can change the groups around. Now, does this work for all types of rational numbers? Yes, it does. Let's try an example with integers. -4 plus the quantity of a -5 plus a -6. Does that equal -4 plus a -5 plus -6? Well, let's just check it out and see if it does. -5 plus -6 is -11 plus a -4 equals -15. Let's check it out and see if it's true over here. -4 plus -5 is a -9 plus a -6. Negative plus negative is always negative, no matter what. So a -15 equals a -15. That is true. Will it also work for fractions? Let's see. Okay, let's write this down. How about 1 1/2 plus 1/2 plus 2? Does that equal 1 1/2 plus 2 plus 1/2? Well, let's see. 1 1/2 plus a half is 2 plus 2 equals 4. Is that the same thing as 1 1/2 plus 2, which is 3 1/2 plus a half, which will also equal 4? So that is true. It checks out. Okay, associative property will not work for subtraction. It's just like the commutative property. It does not work. Let's write that down. Associative property does not apply to subtraction. Okay. Go ahead and add another page, and we'll just talk about the identity property. Okay. Our identity property of addition simply says that A, for any number, A plus 0 equals A. And A can be any rational number. That means it can be an integer, a decimal, a fraction, whole number. It doesn't matter. They all work. If you add 0 to any number, it will always be the same. Okay. The only other thing I wanted to show you is I just want to show you a real quick visual to help you with the commutative property, especially with the negatives. So let me just add one more page, and I'm going to write a little number line here. Okay. And I'm going to write the problem -2 plus 4 and show you that on a number line. Okay, if I start at a -2, okay, if I start there and I add 4 units to that in a positive direction, because it's a positive number, this is like my balloon starting at -2, and I want to go 4 units in a positive direction, 1, 2, 3, 4, okay, plus 4. I land at 2. Okay, so that equals 2. Let's prove that it's true with the commutative property. 4 plus a negative 2. Does that also equal 2? Now it's very important when you switch your numbers, when you're using the commutative property, if you're talking about positive and negative numbers, you must keep the sign with the number, okay, when you switch the order. Okay, so we would start here now. We would start at 4. Okay, and we would go negative 2, or we'd go 2 units in the negative direction. So we would go 2 units in the negative direction plus a negative 2, and we land at 2. So it is true, the commutative property works, but we must keep the signs with the number. So let's make sure we write that. Must keep signs with numbers when we switch. Okay, I hope that the robots helped you understand the commutative, associative, and identity property a little bit better, and I hope you took some very good notes. Okay, please email your note to your teacher and complete the note check if you haven't already. Bye for now.